I will be giving an introduction to the Clojure backtesting library, which is basically a backtesting framework for quantitative investing and trading, written in pure Clojure. First, I will talk about the environment requirements of the library, which are listed here. So you should have Java installed on your computer as well as Clojure Line Engine. Let's verify my installation on my own computer to give you a reference. To verify Java installation, you can simply input Java version. It is outputting Java 14, which is acceptable. Actually, I recommend you to have Java 8 or plus on your computer. And for the Clojure Line Engine, it is kind of like the combination of the Clojure development tool, like a JDK, and also the package management tool for Clojure. So Line is like a complete tool if you want to develop in Clojure. And to verify its installation, you can input line version as well. Here is outputting Line Engine 2.9.5 on Java 10.0.2. So basically, Line Engine and Clojure in general is developed based on Java. Although you are written in Clojure syntax, when you execute the program, it is actually compiled to a Java understandable bytecode. So the underneath of Clojure is still Java. That's why executing a Line Engine program is relatively fast. Okay, here are the basic requirements, and optionally, you can have Jupyter Notebook installed on your computer, which we will explain later. There are mainly three ways that you can run the program. We recommend you to run it locally using the first two methods. One is using the line repo. The pros of this method is that you do not need to install extra softwares. As long as you have the basic requirements installed on computer, you can use this method to run the backtester. And secondly, you can use a Jupyter Notebook, which is well known for Python developers, right? And the pros for this method is that you can save strategies in the notebook format. So you can retrieve your strategy later and run it again, which you cannot do in a Line Engine repo method. We will talk about how to use them one by one. First, the Line Engine repo. To use it to use Backtester in a Line Engine repo, you should first clone the repository and decompress it, and enter the same directory of the project which I'm in right now. You can see I'm at the Clojure backtesting library project. You should run below command in the terminal to start the Line Engine repo. Run line repo to start the repo. Repo is just an interactive shell of Clojure. In Python, you can have similar shells by typing Python in your command, and you can interactively manipulate the program. And thirdly, you can run the examples in the example folder. We will do it later at the second part. The Line Engine repo will take a while to compile and start. Normally speaking, you should wait for 1 minute. But if you are running the program for the first time, it will download a few dependencies, which will take longer time. Okay, now the Line repo has started successfully, and you will see the output like this. Starting here, you can type whatever Clojure code you want, and it will execute for you. For the Jupyter Notebook method, detailed installation instruction can be found here. Let's go here. Here, I'm actually at the Clojure backtesting website. You can find a bunch of contents in the left bar. we are at this Get Started page. You can see the content list here. We are at this Setting up the Playground section. And let's actually go through this page step by step so you can have a basic understanding of the system. We have already talked about the LineGen repo platform. Now we are at the Jupyter Notebook platform. First, to start the Jupyter Notebook, you should have it installed on your computer. To verify the installation, you can do Jupyter version. It's important to have the Jupyter Core and Jupyter Notebook installed. Secondly, after you have installing the Jupyter Notebook, here the instruction actually splits depending on the computer you are using. So I will demonstrate the way to install the backtesting on a Linux or Mac machine. And if you are a Windows computer user, you can follow the another guide. It's easy to install backtesting library on Mac. You can simply run make add kernel. Also, again, you need to make sure that you are under the directory of the project. This command will also take a relatively long time. It will need to compile the system and install it to one of the kernels of the Jupyter Notebook. See the successful output here. It said installation successful. Then it means you have successfully installed the Clojure backtesting library as a Jupyter Notebook kernel, and of course you can run the backtester in the Jupyter Notebook. So moving on, here are actually a few Clojure beginner tutorials I found and recommend for you guys if you are new to Clojure. This one is a great tutorial by writing real codes right after the documentation, and so on. And in case you would encounter difficulties in using the backtester, feel free to post it in the issues page of our official GitHub. We very much appreciate that. And finally, I would like to give a brief code walkthrough of the simple trading strategy in the examples folder. This is just to give you a basic understanding, a taste of the backtester. You do not need to worry too much if you don't understand one or two specific codes. You should just try to understand how the backtester normally works. First of all, when you start writing or developing on the backtester, please first import all the necessary libraries in the backtester library. Just copy this block of code to the first line of your program. That you'll be fine. After that, import the dataset. Okay, let me actually give you a live demonstration using my computer on the LineGen repo, and you can also try it yourself on your own computer using either this LineGen repo way or the Jupyter Notebook way I just mentioned. Okay, just copy this line. This is to load the dataset that includes all the information for the stock market. I believe for America during 1970s to 2010s. Here, please also remember to replace this line of code to the actual path or relative path of the dataset on your own computer. I would actually talk more about the CRISP dataset. Here in the user guide, you'll find more information about the dataset, essential column names. So CRISP is the official dataset for the backtester. New users are recommended to use directly this dataset in the backtester because although the backtester supports other dataset, but the dataset needs to be processed by a specific script in order to be compatible with the backtester. So to reduce the overhead you may have, just simply use the CRISP dataset if you are a new user. In the CRISP dataset, this is a CSV dataset which has multiple columns, but the few necessary ones are PRC, which indicates the closing price, the open PRC, which is the opening price, the date, intuitively it's the date of the record, and the terminal, which is the security identifier. In the backtester, as well as in the real stock market, you should know that we are trading on securities, and the terminal actually indicates unique security codes. Also, APRC, this is generated by us, which indicates the adjusted closing price. And the actual parameter add APRC is used to add APRC this column. Of course, when you run the code, it will return the date range of the dataset. In our case, CRISP is ranging from 1972 to 2017. And moving on, we should call init portfolio. This function generally is the function that you can use to state your initial position. The first argument is to state your starting date, and second one is to state your starting capital, which is in the form of cash. Okay, let's run this. Okay, returns date, the actual date you are at, and the cash you have. Please note that although you input some dates when you call init portfolio, you may find the return date relatively different from the one you input. That is because the CRISP dataset is not continuous. As in the real stock market, the market will stop at, for example, weekends or holidays. That's also true of the dataset. So we will actually pick the closest date to your input date in the dataset and make it your starting position. So please double check the return of the init portfolio to really make sure that which date you are actually at. Okay, and now we have introduced another concept, which is the global date pointer. The date indicates here. Let's go back to the user get page, and you will also find trading logic external link to the time pointer. The backtester is used to simulate real-world trading situations. Therefore, there is a date pointer in the platform that users can move forward through time, and they cannot go back as in the physical world. This date here indicates the current date of your backtester, and all the orders you make, all the evaluations you make will be rooted in this date, and you are able to move forward in time but not backward. After stating your initial position, you can do a few things. Actually, a few things, whichever you want. Here, you can first check what are the available terminals. Remember, terminal is the unique identifier for securities. So here you are actually checking what are the available securities I can trade today. It will return you quite a long list of available terminals, and you can choose whichever and actually which collection you want to analyze and order. This leads to the main issue, which is how to write your own strategy in the backtester. Here, let me illustrate or use this simple strategy as an example. I will trade in the time span of 10 days. The strategy is quite simple. I want to buy 50 stocks of terminal 14593 on the first day, and I will consecutively sell 10 of them on each and other day. Right? It's super simple. Oh, it's not actually on every other day. It's on every other odd dates. I will explain later. Here, this is the remaining counter. The initial value is 10. I will decrement it every day. While loop, make sure you have a basic command of the clojure syntax before you can understand this line of code. While loop, for the positive number of days. Remember, in the strategy, for the first day we will buy 50 stocks. So here, if the number of days is 10, which means I'm currently at the first day, I will order 14593 for 50 shares. And the print true means I will print the result of my order on the screen. By default, it is set to false. And according to the strategy, if the remaining number of days is odd, I will then sell 10 stocks and print the result on the screen. You may notice that I wrap my strategy in a while loop. So this is actually a good practice because, as I said, you are under the simulation of the real world timeline. So as in the real world, you make strategies in daytime, and you probably will continuously do that every day. So wrapping your strategy in a while loop will make sure that you the strategy of yours will run every day. And of course, remember to call the function next state within the while loop, or actually in the condition of the while loop, to move the time pointer forward. Coming back, this update evaluation report function will update the evaluation metrics when you call it. This will actually, intuitively speaking, insert a new evaluation record to the list of evaluation records, which includes columns such as Sharpe ratio, maximum drawdown, and so on. This is simply the evaluation report you can print at the last of your strategy. I actually recommend you not calling it frequently, because it actually will cause a computing overhead. So please just try to update evaluation report when you have made significant change on your portfolio, such as buying stocks or selling them. And the getDate function will print the time pointer. And next it will, as I said, move the time pointer forward. And remember, at last decrement the remaining time counter. And here are the outputs of the above program. You can see on date December 16th, which is the first day, I ordered 145,934.50. But you may be curious, why in the order receipt, right? The date here shows December 6th, 17th. It is strange, right? Because I made the order on 16th. Okay, so this points out to the trading logic of the backtester in the user guide. Actually, I won't go much more detailed in this presentation. You are very welcome to read it on your own about the trading logic, which is basically a delayed close of order. Your order will be transformed into pending orders, and which will only be closed on the future days. Yeah, and the strategy has been overall executed. This is a necessary step to end order. This is actually to deal with all your remaining shares of stocks to sell them on the current trading price to give you a fair evaluation of how many cash you can receive at the end, comparing what you have initially. And you can do some evaluation tasks. For example, print all order record. Here, without any argument, you will print all the records. If you input a positive number, it will return the first n lines of the order record. Also, you can view portfolio and portfolio records by these two functions, print portfolio. You may find here you have only one type of capital, which is cash. That is because you called end order. But if you don't call it, you will see multiple capital source. Of course, you may have the terminal stocks, which also have a expected value. And print portfolio will return some portfolio analysis record for you every day. Finally, you can generate the evaluation report. As I said, the previous update evaluation report is a preparation for this evaluation report. All of these print functions have similar syntax. You can either input nothing, which will print the whole list, or you can input a positive number to make it print only the first few lines. The evaluation report contains many useful information, and you can find a detailed definition for the columns in this evaluation page. Okay, last but not least, plot variables. We also allow users to plot what values they want in the screen, no matter which method you are using, the REPL way or the Jupyter Notebook way. The syntax are here. You can check it and run it on your own computer, and you will find this output diagram the same as the one shown on the website here also. The first plot is about the daily return, and the second one is about the volatility. Yeah, so that's the whole walkthrough of the Get Started page. Here is a tip about reading the Clojure backtesting website. Remember where I find this website is from the README file in the official GitHub account. Here. In the GitHub page, there will be multiple references to the website. And moving on to the website, this is the home page. This is just a introduction to the to the backtester. And at the bottom, here's the table of contents. My recommendation is that you go through every page of this one by one in sequence. these pages are introduced in the order of difficulty. So if you are new to the backtester, I recommend you to go the get started, then the user guide, which talks about some prerequisite information about the dataset, as well as some important details of the backtester, and then go through the API documentations divided by function. First, the basic APIs, talking about the basic API used to interact with the backtesters, for example, load dataset, making orders, and so on. Then how to manage portfolio, how to do evaluation, how to calculate indicators, and how to change some predefined parameters. About this indicator, our backtester also comes with some built-in definition for a collection of popular market indicators such as moving average, moving standard deviation, EMA, MACD, rate of change, relative strength index, right? All popular indices that help you analyze the stock market and making the right decision. Finally, you can go through some examples we wrote for you. For example, we have just walked through the simple trading strategy, but there are also others such as Bollinger Bands and buying our margin, golden cross, etc. So that's all for the introduction today. Hope you enjoyed the video and find our backtester useful. Thank you so much.